In the vast expanse of the cosmos, danger looms, silent, unyielding, and catastrophic. Humanity's survival may depend on what we do today. In April 2024, NASA conducted its 5th biennial Planetary Defense Interagency Tabletop exercise to prepare for a scenario many of us fear: an asteroid on a direct collision course with Earth. With a 72% chance of impact predicted for July 12, 2038, this exercise revealed unsettling truths about our readiness. What are the gaps in our defense? Could technology like NASA's DART mission or the upcoming NEO Surveyor save us? Or are we barreling toward a future of chaos and destruction? Let's unravel the truth behind this simulation, the exaggerated media frenzy it sparked, and the harsh reality of humanity's vulnerability. Is the Earth truly prepared for Apophis, or are we staring at the beginning of the end? Before we get started, make sure to like, subscribe, and hit the bell icon. The exercise that shocked the world. Imagine a world teetering on the brink of annihilation. That's the scenario NASA presented to nearly 100 experts from over 25 organizations, including the Federal Emergency Management Agency, FEMA, and the Department of State's Office of Space Affairs during its Planetary Defense Tabletop exercise at the Johns Hopkins Applied Physics Laboratory. The dates: April 2nd and April 3rd, 2024. This wasn't just a brainstorming session. It was a high-stakes simulation aimed at answering one critical question: are we ready to face an asteroid impact? The answer, as we'll soon learn, was as sobering as the stars themselves. The stakes? Immense. In this scenario, scientists had discovered a massive asteroid with a 72% probability of striking Earth on July 12, 2038. But there was a catch. Early observations left too many questions unanswered. Size? A mystery. Its composition? Unclear, and its trajectory? Uncertain. The experts were left to work with fragments of information, much like they would in a real-world emergency. But here's where the situation becomes even more dire. In the simulation, the asteroid, let's call it Apophis, disappears behind the sun for a staggering 7 months. 7 months without crucial data. 7 months of global panic. What would you do, knowing an asteroid could wipe out cities like Washington, D.C., Madrid, or Algiers? An asteroid strike is no ordinary disaster. It's the ultimate equalizer, capable of reshaping life on Earth in an instant. NASA's scenario predicted that an asteroid between 200 and 2,600 feet wide could strike with devastating force. To put that into perspective, the smaller end of the scale matches the Chelyabinsk meteor of 2013, which injured 1 to 500 people and damaged 7,000 buildings. The larger end, catastrophic enough to kill millions and plunge the world into chaos. The target date? July 12, 2038. The potential death toll? Anywhere from 1,000 to 10 million people. Let those numbers sink in. But it's not just about lives lost. An impact could trigger global economic collapse, widespread famine, and an environmental crisis that would make today's challenges seem trivial. And yet, as the simulation revealed, humanity's ability to respond is disturbingly inadequate. Segment 2. The glaring gaps in readiness. So what did the experts uncover? First and foremost, a lack of global coordination. In a real scenario, nations would need to act swiftly and decisively. But political red tape, funding battles, and jurisdictional disputes could delay life-saving missions. Second, a troubling lack of decision-making protocols. Should we wait for more data or launch a mission immediately, risking billions of dollars on incomplete information? These questions, though hypothetical, carry real-world implications. Finally, there's the question of technology. While NASA's DART mission proved we can redirect asteroids, scaling that success to a larger, faster-moving target like Apophis is a different story. And with a price tag of $400 million per mission, the question remains, would governments be willing to invest in time? But there's hope. On September 26, 2022, NASA made history. Its DART mission successfully altered the orbit of an asteroid for the first time, proving that kinetic impact could work. This breakthrough was hailed as a turning point in planetary defense. But here's the catch. DART targeted an asteroid just 530 feet wide, a pebble compared to Apophis. Would this technology work on something larger, faster? Enter the NEO Surveyor, NASA's next big leap in asteroid detection. Slated for launch in June 2028, this space telescope will use infrared technology to identify hazardous objects hidden in the sun's glare. By detecting threats years in advance, the NEO Surveyor could buy us the precious time needed to act. Still, technology alone won't save us. It's a race against time, bureaucracy, and misinformation. When the exercise results were released on June 20th, 2024, some media outlets took the story out of context. Sensationalist headlines fueled panic, claiming NASA had issued a real warning about a 2038 asteroid strike. Others misrepresented the findings, suggesting humanity was hopelessly unprepared. But here's the truth. The exercise was a simulation, a test, not a prophecy. So, where does that leave us? NASA says we've never been more prepared. But the tabletop exercise also revealed critical gaps that could mean the difference between survival and extinction. Will nations work together to fund asteroid defense programs? Will the NEO Surveyor launch on time? Or will humanity's fate be decided by delays, debates, and denials? The constant rain of cosmic debris. Picture this. Every 90 minutes, somewhere on Earth, a meteor makes its fiery descent, hitting the surface with varying degrees of force. Sounds alarming, right? But here's the truth. It's not the headline-worthy apocalypse most imagine. On average, the Earth is hit by 6,100 meteors each year that survive their fiery journey through the atmosphere and strike the ground. That's approximately 16 meteors per day, or one impact every 86 minutes. Now, before you panic, let's break this down. First, about 2/3 of these meteors land in the oceans, causing nothing more than a few splashes in the vast, uninhabited waters that cover most of our planet. That's 4,000 meteors a year that quietly disappear beneath the waves. But what about the remaining 2,000 meteors? These do hit land. Still, Earth's landmass is a staggering 57.5 million square miles, with only about 16 million square miles being habitable. The odds of a meteor landing within a mile of you are about 1 in 8 million each year. In other words, you're more likely to win the lottery multiple times in a row than encounter a meteor strike close to home. So yes, asteroid impacts are an everyday phenomenon, but they're rarely significant enough for us to notice. The real concern arises when we start talking about asteroids that are big enough to care about. That raises two important questions. One, how big is big enough? Two, how do we calculate the probability of an asteroid of that size striking Earth? To answer the first question, let's consider size. A typical asteroid needs to be at least 100 feet in diameter to cause significant damage. For reference, the Chelyabinsk meteor of 2013 was about 66 feet wide, and its explosion injured over 1,500 people, despite not even reaching the ground. Now imagine something 10 times that size, like the asteroid that created the Barringer crater in Arizona, which was over 160 feet wide and released energy equivalent to 10 megatons of TNT. But when we start talking about truly catastrophic impacts, ones capable of wiping out cities or even civilizations, we're dealing with asteroids over 0.6 miles wide. These are the ones that could trigger mass extinctions, like the infamous asteroid that struck Earth 66 million years ago, wiping out the dinosaurs. Now for the second question. How do we predict the path of an asteroid? The answer is we don't, at least not with absolute certainty. Predicting the trajectory of an asteroid 14 years into the future is like trying to predict the exact path of a leaf falling in a swirling windstorm. The gravitational pull of the moon, the sun, and even distant planets subtly alters an asteroid's course over time. These influences, while tiny, add up to a chaotic web of possibilities that make long-term predictions incredibly difficult. That's why most astronomers focus on asteroids that pass within the orbit of the moon. Anything closer than that is worth monitoring. Even then, Earth is a small target in the vastness of space. So should we worry about Apophis or any other asteroid right now? Probably not. While the 72% probability assigned to NASA's simulation sounds alarming, it's important to remember that this was a hypothetical scenario designed to test readiness, not a prediction of doom. The truth is, asteroids strike Earth all the time, but most are too small to cause any harm. Even in 2038, we can expect around 6,100 meteor impacts, a number well within the norm. The key difference lies in the size and trajectory of the asteroid. Only those with the potential for widespread damage are cause for concern, and thankfully, these are exceedingly rare. But rare doesn't mean impossible. That's why we need initiatives like NASA's NEO Surveyor and successful missions like DART. These advancements could be the difference between a near miss and global catastrophe. Apophis and the dance of potentially hazardous asteroids. After decades of study and speculation, Earthlings can finally breathe a sigh of relief. NASA has officially confirmed that the planet is safe from Apophis, the once feared asteroid, for at least the next 100 years. Discovered in 2004, Apophis, named after the ancient Egyptian god of chaos and darkness, quickly earned its reputation as one of the most dangerous asteroids to threaten Earth. Early calculations predicted close calls in 2029, 2036, and even a slight risk for 2068. But thanks to advanced radar observations during its recent flyby on March 5th, astronomers have refined their calculations. The verdict? Apophis poses no impact risk for at least a century. Mark your calendars for April 13, 2029. The date of Apophis's unprecedented close approach. On that day, the asteroid, measuring an estimated 340 meters, 100 feet across, will pass within 32,000 kilometers of Earth's surface. To put that into perspective, this is just 1/10 of the distance between Earth and the Moon. It will be so close that no telescopes or binoculars will be needed to witness the spectacle from the Eastern Hemisphere, including parts of Asia, Africa, and Europe. For those regions, Apophis will light up the sky like a fast-moving star. NASA's radar imagery of Apophis during its March 5th flyby was so sharp that, as one scientist put it, if we had binoculars this powerful, we could sit in Los Angeles and read a dinner menu in New York. These refined observations allowed scientists to eliminate the slim risk of a 2068 impact, officially removing Apophis from NASA's risk list. But while Apophis is no longer a concern, other potentially hazardous asteroids, PACE, remain on NASA's radar. Here are three of the most notable ones. 1950 DA, measuring 1.3 kilometers. It was first discovered in 1950 and rediscovered 50 years later. It has a 0.012% chance of impact on March 16, 2880, though the odds remain astronomically low. 2010 RF-12, topping NASA's watch list in terms of impact probability. This asteroid has a 4.7% chance of striking Earth on September 5, 2095. However, its small size, just 7 meters in diameter, means it wouldn't pose a significant threat. 2012 HG2, this asteroid, measuring 14 meters, has the highest number of potential Earth impacts on record. The first could happen as soon as February 12, 2052, but like 2010 RF-12, its small size makes it more likely to burn up in the atmosphere. The vast majority of these near-Earth objects burn up harmlessly in our atmosphere, a testament to the protective cocoon surrounding our planet. Yet vigilance remains crucial. As NASA's Davide Farnokia explains, removing Apophis from the risk list is not just a victory for science. It's a reminder of how much we can accomplish when we focus on tracking and understanding the threats from space. Now, the focus shifts to the science we can uncover during Apophis's 2029 close approach. Its proximity will provide astronomers with a rare opportunity to study an asteroid up close, potentially revealing new insights into the composition and behavior of these celestial wanderers. As for us here on Earth, the story of Apophis is a reminder of our planet's place in the cosmos, small, vulnerable, yet remarkably resilient. And while the sky may hold its threats, it also holds endless wonders waiting to be explored. What do you think about the cosmic threats we face? Does the story of Apophis reassure you, or does it ignite curiosity about the mysteries lurking in the depths of space? From Apophis to the countless other asteroids zooming past our planet, the universe remains a place of wonder, danger, and discovery. Keep watching the skies, because there's always more to uncover. Thank you for joining us on this journey.